So I know we're short on time, so let's just kick it off, everyone. Thank you very much for joining. I'm super excited to be the first one to open this 24-hour live stream. Hopefully the internet will be good, and we'll pray for the webinar gods this time. So we'll all be having a good time. I will be taking questions and answers in the end, so feel free to put them in the chat, and I will hang around in the lobby afterwards if need to. Without further ado, let's kick it off. So yes, one can simply Terraform their app to Azure easily. What are we going to talk about? So I'm Omer Barel. I'm a DevOps architect and tech lead in Code Value. Been here for almost 4 years now. I've been strong around Terraform, Kubernetes, and other stuff. And let's jump right into the agenda real quick. So we're going to start with some challenges with our infrastructure deployments. Deploying infrastructure is not that easily, and there are some challenges there. And the whole purpose of this talk is to try and tackle some of these challenges and show you what you can do to overcome some of the pitfalls in that deployment. We're going to take a look at a demo application that I have. I'm going to look at the overview of what the application holds. It's a cloud native simple application. And just so we will have some meat for our presentation. And then we're going to discuss a little bit about the developer inner loop. How are you as a developer, as a Terraform infrastructure developer, work with this process? And then we're going to take it away to a more deeper CI/CD process to deploy it to multiple environments, to development environment, to other QA and production environments. And I will also want to touch base a little bit about security and governance that we have placed into that process. And we'll finish off with what the future holds and some things we want to add to this process. So in 2 seconds or less, a little bit about me. Husband to Nama and father to Leo and Theo. And I love whiskey and traveling. I prefer to do them together if possible. This is why I do what I do all the time when I give talks. It's for them. This is what drives me to move forward. And I've been deeply invested in the Kubernetes and Terraform community, and I'm strong around that. You can find me on Twitter at Omer Barel if you would like to discuss some more later. And let's jump right into the challenges. So how can we do CI/CD for infrastructure? It's pretty straightforward today to do it for application. You have even templates in a lot of the systems that if you want to build your application from .NET, Python, or whatnot, Node.js, you have even built-in templates and built-in logic on how to do that. There's not so much logic or best practices into how to do it for the infrastructure piece. How can we version our infrastructure? It's very common to use versions in our application, but how do we do that for infrastructure? How do we roll version 1 from development to production and so on? How can we deploy our infrastructure to subscriptions, particularly Azure in this case, that we don't even have access to them? So production should probably be a more tight environment that not everyone can touch. Maybe even ourselves cannot touch it as developers. But how can we deploy it even if we don't have access? And during that process, I'm going to touch a little bit also about how to reduce cloud costs. How can we tag our resources during the deployment? How can we look at that later on? How can we deploy and destroy our environment on the fly to reduce costs if we don't need to? So these are some of the challenges that basically raises the questions, how do we handle our infrastructure the same way we handle our application? Because we have those processes in the application, but how do we do that the same for our infrastructure? And the answer, simply put, is Terraform. And we have that as infrastructure as code. We'll talk a little bit about Terraform. There are other alternatives in the market. If we look at Azure, there are ARM templates. If we look at AWS, there is CloudFormation and others. But why should we use Terraform for that? Why is Terraform the right tool for that? And to me, what I found, and this is what I want to deeply touch in this talk, is the logic that is built inside Terraform that can be easily implemented into the process. So hopefully, you know Terraform a little bit and Azure a little bit. This is an intermediate level kind of talk. So if you know the Terraform flow, you know you can do like Terraform plan for a dry run to basically see what's going to happen before you actually do that. And then you do the Terraform apply, which will basically modify your real infrastructure. But that plan phase, when you can also do like an artifact, like a plan, an artifact, a real file, is basically our CI process, or at least the start of our CI process. We can take that as an artifact and move that into our environments and use that in release pipelines for different stages. So we'll see that in a minute. But the main takeaway is that there is a built-in logic inside the Terraform loop to help achieve those CI/CD processes. So this is our application. It's a cloud-native application, a very simple one that basically shows 4 microservices. And let's just touch a little bit about that. Let's take the pen here. So we have, in GitHub, we have all our microservices. We have 4 microservices: Fifi, Parrot, Captain Cube, and Node Brady. And then we will start by connecting that into Azure build pipelines, which is right over here. And we're going to do a CI per microservice, sorry. And then side to that, a CI per our infrastructure, same as we do for the microservices. And then we're going to attach all of it into a single Azure release pipeline, where the deployment will deploy our infrastructure. And on top of that, we'll deploy our application. The infrastructure in this scenario is a Kubernetes cluster, a managed Kubernetes cluster in Azure, AKS, that is the main infrastructure piece with all the VMs and whatnot. And then we will add a few components into that, such as namespaces and secrets and user accounts potentially. And then on top of that, we will take each application with its own Helm chart, and using, again, Terraform with different providers, we will deploy those as part of our pipeline. So this will be our release. So we will touch on all of those. And as I said in the beginning, I just want to emphasize, I will touch more on the process right now, but don't worry, everything that you will see in this demo, in this presentation, including the code in GitHub, the release pipelines, the build pipelines, everything is open source, and I will share it with you in the end of this slide. So you will see everything hands-on. I won't really do a demo because it takes time to deploy that, so I didn't want to waste the time on actually deploying the infrastructure, but everything is for you to see, and it's completely open source, and you can see that later on. Okay, so let's continue. So in a very high level, this is the process that we are talking about and with regards to the infrastructure. So we have, first of all, on day 0, basically, we have our master branch that we start, and it's very clean. We're not touching it that much. So on day 0, we will go and branch out to a developer branch where we will do the development and the development environment. And as a developer that I'm developing the infrastructure, again, this is not the application, this is the infrastructure, I will branch out to some feature branch. Maybe I want to add the number of VMs. Maybe I want to add a service, like a database, to my infrastructure. So I will step out or branch out to a feature branch, and here will happen all the development in a loop. As a developer, I will push and commit into the feature branch. And once I feel comfortable with my infrastructure, and maybe I even have the possibility to do a Terraform plan from my computer, but it's not necessarily, I will try and validate and create a pull request into the developer branch. At this phase, the CI/CD process really starts, the very first step, where I'm going to run some pipeline that will validate my code. And it will basically be a Terraform init and plan, but I'm not going to create any artifact. I just want to make sure that the plan works. I can merge it into the development branch. Once I've merged the code and the development branch has the latest updates, this will trigger another task, which is very similar to the initial task, but it will create a build and will create the artifact. And the artifact is basically our plan artifact. And this, if you have, there was an official document from Terraform on how to run build, plan, and apply on different machines. So basically, if we take all the Terraform code in our source code and the Terraform plan, we can be sure that this is the exact plan that we can run on every machine. So we can take this, and this is basically our desired scenario, and we can go ahead and run it on any machine. So we're going to take this in our pipeline, and this will trigger the creation of that artifact, will trigger a release in Azure release pipelines, and this will deploy, first of all, to some, what I call a DevOps environment. It can be a dummy environment, a mock environment, whatever you want, but this is basically the very first environment that just validates our infrastructure code. We're not necessarily going to deploy application here. We're not going to have developers of the application connecting to that environment. This is more for us as Terraform developers to validate that our code passes all the stages and can actually be deployed into the environment. This is important since some steps are not captured during the plan phase, and some scenarios might not happen. So for example, you might have a storage account in Azure that the name is not unique. And if you know a little bit about Azure, storage account have to have unique names. So in the plan phase, it might not catch that because that's an API response from Azure. But when you actually apply that, you can get an error for that. So this is why it's important as part of the process to actually deploy the infrastructure before we roll it out to other environments. Now, the next phase will be very similar to this, but just deploy it into the dev environment, usually also from the dev branch, although there is a lot of give and take here, and you can adopt it to your own needs. But what I feel the most comfortable is that once this has passed, there is also another build that can kick in that will do the same flow, just to a different development environment. And then once we feel comfortable, then we can say, okay, I have a stable version of my infrastructure that I want to start rolling out to more mature environments like QA, staging, production, and whatnot. At this phase, we will do a pull request from our dev branch to our master branch. We're not going to do too much validation in that phase because we did a lot of the validation in the lower section of the screen. We have validated as much as we can in this phase, but this will be a governed merge. So maybe someone needs to approve that, or maybe we want to do that just at the end of the sprint or anything. So this will be more of a challenging merge. And then once that's merged, we will tag our infrastructure. We will tag our sources with a specific tag that gives us a tag of our infrastructure that we can go and roll out to different environments. Tagging our sources can help us do that in the future. Maybe we want to roll back to a specific version. Maybe we want to take it and just deploy it in 5 days' time or something. So the tag gives us a checkpoint that we can take to other environments. This is how it looks in a little bit lower level, the continuous integration and even deployment piece. And again, this is the continuous integration and deployment of the DevOps environment gives us a more robust testing. So we're going to clone our infrastructure. We're going to install Terraform on the build agent. This is actual, sorry, I forgot to mention that. These are the actual steps that's going to happen in our CI and CD pipelines. We're going to initialize Terraform. Usually with some remote state backend like Azure storage account or whatnot. We're going to select an environment. So an environment in Terraform, if you're familiar, equals to a workspace. This gives us a single code, but with multiple instances of that code. So from the same code template, we will have it deployed to multiple environments. So we will select, for example, the DevOps environment. We're going to run Terraform validate for basic testing, and the Terraform plan, which is basically the dry run that will give us even a little bit more testing. We're going to create that artifact I was talking about, the plan phase, release the trigger, and then again, we're going to deploy a release pipeline. And again, the agent might not be the same. If you're using hosted agents in Azure, you know that you're not selecting the agent, so it might not have Terraform, or it might be your own agent pool with several machines. So it doesn't necessarily mean that this release phase will have something. So we will again install Terraform, download the artifacts from the previous state, and we're going to deploy our infrastructure wherever that may be. So we have Terraform, we have Azure services, we have Kubernetes cluster, we have databases or whatnot, but that's the infrastructure phase. And then we will deploy our application. So this really is a unique case-by-case scenario. You might sometimes have applications, such as the one I will show you, that has a built-in Terraform provider, for example, for Helm charts, that you can use Terraform as a one-shot to deploy all the stack. You might have scenarios such as a platform as a service environment where you don't have Terraform built-in tools to do it. For example, you want to deploy a static website in Azure. So the data of that website needs to come up to Azure some way. You can do that in a script like AZ storage blob upload that will run by Terraform, or you can do it as a different step in Azure DevOps. That's really up to you. An important thing is that, for example, for the DevOps environment, we will also do a destroy of the environment. Again, we do that for two main reasons. First of all, to reduce cloud costs. The DevOps environment, once we validated it's working and we can deploy it, we not necessarily need to keep that for a long time. Maybe we will do the destroy an hour or two later. Second thing is that even during the destroy phase, you get a value of testing some of the scenarios. So for example, when you deploy a key vault in Azure, you deploy an access policy, and you might even deploy a secret into that key vault. If you haven't put dependencies in place, you might accidentally, when you destroy your infrastructure, destroy the access policy before you destroy the secret, which basically breaks your permissions. So even during the destroy phase, you can capture some errors or some bugs in your code that you haven't really thought about in your process. So it's very much valuable to test the destroy process as well, as in addition to the apply phase. One thing I want to touch on, just a little bit. I'm going to dive a bit deeper into that later. Is the use of Azure Key Vaults. So as a backend to our entire process, we will store sensitive credentials in Azure Key Vault. So think about the client ID, client secret, subscription ID, and I'm referring to the client that will run this entire pipeline. So for example, when you set up Terraform to work against Azure, you create some service account for Terraform, giving it, let's say, contributor access to your subscription, and it will run all that for you. You're not doing it with your own credentials usually. But you want to pass all this on to your pipelines as much as possible. So we will use Azure Key Vault, and we will propagate that as secrets and parameters into our pipelines. Let me move quickly. I see that we are a little bit short on time because we started a bit late, so I will run quickly. And if we need to, we'll steal a few more minutes. So this is the dev branch. We will do the DevOps environment and maybe even the dev environment. And then once we have that, we said we're going to do a merge into the master branch. And from the master branch, we will run, again, another CI, as you saw. But then in the CI, we're going to have artifacts for each environment. So we will have a plan for the dev branch, for the dev environment, for the DevOps environment, for the QA environment, and for the production. And then we will run a release pipeline. So this is the release pipeline, as you can see. Sorry about my drawings. But the release pipeline, again, has its own logic where we deploy an environment and we have gates between environments. So we might say we don't want to deploy to dev before infrastructure is successfully completed, or DevOps environment. We don't want to deploy to QA before we were able to both deploy to dev and destroy infra, because we said we might gain value here. So we have a lot of potential to put in here different steps as gates between our environments. And this is how we leverage Azure release pipelines to basically show the differences between environments and roll our infrastructure into different environments. And this is, sorry, this is, let me just go back for a second. Yep. Okay. Sorry, we'll keep here. So this is how we can see, for example, in the QA environment that I'm saying that it's going to be after a specific stage and only after the dev destroy, and maybe even someone will do a pre-deployment approval and will approve that. Okay, so a little bit about security and governance. So as we said, the Key Vault integration, it's a key to emphasize, because this can be an external interface to IT admins. So for example, they might control subscriptions that you don't have access to, but they will put as secrets the credentials of a user or a service principal that has permissions to deploy to those environments. So you as a developer or as a Azure DevOps admin doesn't have those credentials, but you can leverage them as variables in your pipeline to deploy to different subscriptions and environments. Same with the pipeline variables. Those secrets in Key Vault will become pipeline variables in Azure DevOps, and we can use them without even knowing. This also helps us separate the concerns. So again, as an Azure DevOps admin, I don't want to know about those subscriptions, and I want someone else that is managing security and governance to give them to me. And also, we will have a specific account that only has a read access to that Key Vault to pull those secrets. So the secrets have more permissions, but pulling them from Azure DevOps is done with a specific user that only have access to read them. The Terraform service principle, we just want to touch on that for a minute. It needs to have subscription level access, usually maybe a contributor or maybe to a specific resource group, and also Active Directory access. These are two different providers. So just make sure you look at those two areas. And then we're going to talk a little bit about the governance and environment rollout, where we can roll out the same version between environments, and also the gates that we saw between the QA and the dev and all that. So this gives us a little bit of a governance and control over the overall process. We can do testing in between. Infrastructure testing is very hard, and I will touch about that in a minute, but we can add our own testing between environments. So this gives us a little bit more room for agility and manual override. So we don't want to be very strict in our process. We don't want to say that you can only deploy to production after you deploy to QA. Usually you do, but maybe there is some edge case that you want to really roll something out quickly to production. So there are manual overrides in the release pipelines where you can deploy even if not all the previous steps have completed. Obviously, you want to give that permission only to specific people and after specific approvals. Next steps, we're going to have GitHub releases, Git tags, so we can take that infrastructure and redeploy it whenever we want to. Rollbacks, this is something we haven't touched too much in the process, but something that we develop. How do we roll back a failed deployment? What is the state of our environment right now, and we can roll it back? Developer self-service, so we want to give developers the possibility to do it on their own, using modules, using builds that are already made for them in Azure DevOps that they can trigger on their own, that maybe set up an environment in the morning and then destroy it in the evening, again, to reduce cost and all. Blue-green deployments. A lot of times you don't want to update your environment in place. Maybe there is a huge change that will break a lot of stuff. So you want to create a new environment such as production 2 and only then migrate the data or migrate the traffic into that. So this is another tackle that we are dealing with. And true infrastructure testing. Just deploying the infrastructure end to end and deploying the application doesn't necessarily mean that everything is working. You might want to do use frameworks such as TerraTest or Confidence. There are others that you can actually write testing for your infrastructure. So this is another area that we are looking forward to look in. So a little bit of reference links for you to use. Obviously the presentation will be also on the website, so you can download it later. But as I said, everything in here is documented and you can use it. It's on GitHub. So we have the GitHub repo that basically demonstrates all that. It's on my repo Django Pro /Terraform CI/CD demo, and you can see all the code. Fifi and Friends, the application itself, it's a separate repo that actually was built by Microsoft that I forked, and you can see how the CI/CD is done there. And then the Azure DevOps project itself is open source. I open it to the public, so you can see what's going on there. You can see all the deployments, and hopefully I will have a minute to even show it to you here. And then there is a blog that we wrote in Code Value about doing that deployment in depth. So you can see a little bit more deep dive into the different stages in the process. So let's finish it off with a few takeaways. So scope allows us to deploy our infrastructure using the same processes and practices we use to deploy our application. We don't want to be different from the developers or the processes that we use, Agile, Kanban, or whatnot. We want to treat it the same way, even though it's infrastructure and sometimes maybe overlooked. We want to adopt the same tested processes to deploy our infrastructure. Terraform has a built-in logic, as we said, with the plan artifact, and with the apply to implement those processes very easily. And Azure DevOps is an enabler for us to do it. Now, I didn't touch on that too much, but you don't really need Azure DevOps just for Azure. You can use Azure DevOps to do that to AWS, to Google, to on-prem. It doesn't really matter because eventually it runs Terraform command line commands. So you can really use that to enable that, but it also enables us to use more advanced and complex scenarios, such as multiple environments in the release pipelines, multiple subscriptions, using the Key Vault integration. And it also helps us find a common workplace to govern and collaborate. So we can do code review, approvals of pull requests between different users, and so on. And Azure Key Vault integrations helps us secure the process and interface with IT and security personnel. So, for example, the service account has been compromised. IT can go change the password, update the secret, and the entire process will just work, and we don't have to touch on that too much. Okay, so that is me, and I'm ready for some Q&A if we have time. I know we're a little bit over time, but if there is a need for a Q&A, we can touch on that.